Hello everyone. We UH302 Group 2 welcome you all to our presentation session based on the topic The Rising Ocean, Climate Change is a Remorseless Threat to the World's Coast. In this presentation, we will briefly discuss the following topics. We will discuss about the different causes of climate changes happening overall. And then we will talk about the effects of climate change we are seeing today and predicting to see in future. Then under rising of water level topic, we will discuss about the rise of water level in different locations through different time periods. Then various troubles the world is encountering due to the water level rise and possible future implications expected from this condition. Then finally we will talk about the preventive measures we can take to get rid of this problem. Although the satellite data have shown the minimal role of solar intensity variation, still it cannot be neglected entirely. It might have some effects at a significant time scale because the energy variation is not so high concerning the absorption of that by the earth. The sun follows a natural 11-year cycle of small ups and downs in intensity, but the effect on the earth is negligible. However, over the same period, the average global temperature has increased markedly. Volcanic eruptions have a significant role in climate change. Due to the dust, ash, sulfur, and greenhouse gases are thrown into the atmosphere. Ashes and dust hinder sunlight from reaching the Earth's surface and cause temporary cooling. Sulfur dioxide is much more effective than ash particles at cooling the climate. The sulfur dioxide moves into the stratosphere and combines with water to form sulfuric acid aerosols. The sulfuric acid makes a haze of tiny droplets in the stratosphere that reflects incoming solar radiation, causing cooling of the Earth's surface. The aerosols can stay in that stratosphere for 3 years, moved around by winds and driving significant cooling effect worldwide. The amount of sunlight that is absorbed or reflected by the planet depends on the Earth's surface and atmosphere. The ocean, forest, and soil are darker objects, and they tend to absorb more sunlight. Light colored things and surfaces like snow and clouds reflect sunlight. About 70% of the sunlight that reaches the Earth's surface gets absorbed. When ice melts due to natural phenomena, it results in higher reflectivity. Often, it acts as feedback to other processes. Carbon dioxide levels vary in tandem with the glacial cycles. During warm interglacial periods, carbon dioxide levels were higher. During cool glacial periods, carbon dioxide levels were lower. The heating or cooling of the Earth's surface and oceans can cause changes in the natural sources and sinks of these gases and thus change in greenhouse gas concentrations in this atmosphere. These changing concentrations have acted as positive climate feedback, amplifying the temperature changes caused by long-term shifts in the Earth's orbit. Now let's talk about some human-induced causes. The greenhouse effect. When sunlight reaches the earth, some energy is reflected back into space, some is absorbed and re-radiated as the heat energy. Most of the heat energy is absorbed by greenhouse gases and then radiated in all directions, warming the earth's surface. In last couple of centuries, world has encountered a drastic change in the greenhouse gases in the atmosphere, result of which we can see from the temperature increase in the same time period throughout the world. Concentrations of greenhouse gases are continuously rising in our atmosphere. Since the Industrial Revolution, it has been increasing due to various human activities. Carbon dioxide, methane, and nitrous oxide are most abundant in our nature than in the previous 8 million years. These gases cause the greenhouse effect, which makes the surface temperature higher, which leads to abnormal phenomena in our climate, including global warming. Agriculture, road construction, and deforestation can change the reflectivity of Earth's surface, leading to local warming or cooling. This effect is observed in heat islands, which are warmer urban centers than the surrounding less populated areas. These areas are warmer because buildings, pavements, roofs reflect less sunlight than natural surfaces. While deforestation can increase the Earth's reflectivity globally by replacing dark trees with lighter characters, such as crops, the net effect of all land use changes appears to be a small cooling. Emission of small particles known as aerosols into the air can also lead to reflection or absorption of the sun's energy. Many types of air pollutants undergo chemical reactions in the atmosphere to create aerosols. Overall, human generated aerosols have a net cooling effect on the earth. The impacts on the human cycle and climate change systems will probably be distributed unevenly. Some regions and sectors are expected to experience benefits from this, while others will share the cost of these changes. With greater level of warming more than 2 to 3 degrees centigrade relative to 990 levels, it is likely that benefits will decline for the benefactors and costs will increase for the sufferers. Low latitude and underdeveloped areas are probably at a higher risk of climate change. Adaptation potential for climate change impact is considerably expensive with the human system cycle, although the adaptation costs are largely unknown and potentially significant. Climate change decreases the diversity of ecosystems, adding many more species to the rare category each year, making many extinct. Adaptation potential for biological and geophysical systems is much lower than for the human system cycle. The major impacts of global climate changes are manifested in a gradual rise in global surface temperature, melting of icebergs and the rise of sea levels, continuous buildup of greenhouse gases leading to greenhouse effect, depletion of ozone concentration, catastrophic natural disasters and calamities, hurricanes, typhoons, earthquakes, landslides, tsunami, etc., loss of vegetation, plant, animal lives, biodiversities, marine flora and fauna, etc. The widespread retreat of glaciers and ice caps in the 21st century will also lead to higher surface temperatures on land and increased water stress. By 2025, two-thirds of the water population in the underdeveloped third world may be subjected to moderate to high water stress.
আজ থোড়া ভেঙে যায়, কটালে ভেঙে গেল, ফিরে কটালে আবার ভাঙলো, তার কটালে আবার ভাঙলো, ওই ভাঙতে 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 শুরু হয়ে গেল। তো ওইখান থেকে এটার চিন্তা বাড়ি ছিল, এটার পুরো একটা ঘর ছিল মানুষের। এইটা মসজিদ, এইটা মসজিদ, আর এইখান থেকে বড় সোয়াল বাঁধ ছিল, মানে বাঁধ ছিল আর কি, যাতা আসা রাস্তা ছিল। ওই সব নদীর পানিতে সব সব বরবাদ।
আমি যখন এখানে আসি প্রথম যখন পানি ওঠে আমি তো খুব তখন ভয় খেয়ে গেছি যে এত পানিটা আমি কখনো দেখিনি। প্রচুর পানি টানি বেড়ে বাইরে যেতে পারিনি, সবসময় তো ঘরের ভিতরে তো থাকতে হয় আমাদের। এই ভাত রাত রাঁধতে হয় খাটের উপরে স্টোভকে রেখে ভাত রাত রাঁধতে হয় পানি যখন আসে।
This is the life of people residing in Sundarbans today. Not only Sundarbans, in almost all the coastal areas in South Asia and Indian subcontinent are facing the same issue due to the water level rise in the ocean. The role of temperature in landform changes along the Sundarban shoreline is examined in a study. By 2050s, it is expected that the mean summer temperature will rise by 1.5 to 2 degrees centigrade, and the mean winter temperature will rise by 2.5 to 3 degrees centigrade around the forest. Researchers also looked at the water mass properties in the Sundarban from 1980 to 2007 and discovered that the surface water temperature had been increasing at a rate of 0.05 degrees centigrade per year. According to studies, rising surface water temperatures will cause sea levels to rise, perhaps resulting in the loss of forest areas. Climate change may alter rainfall patterns, affecting forest cover and raising local sea levels, resulting in huge land loss. According to CEGIS, climate change induced sea level rise is anticipated to diminish biodiverse areas of Sundarbans from 60% to 30% in the next 100 years, with an 88 centimeter sea level rise. As a result of the planet's systematic warming, the global mean sea level is rising in two different ways. First, the mountain glaciers and the polar ice sheets are melting and adding water to the ocean at an increasing rate. And second, as the ocean getting warm, the water expands and resulting in an increase in volume. Since 1880, the global mean sea level has increased by roughly 210 to 240 millimeters, with about a third of the increase occurring in the previous 2.5 decades. The annual growth is currently around 3 mm each year. Other factors such as ground uplift or subsidence, changes in water tables owing to water extraction or other water management, and even the effects of local erosion can all play a role, but very small. When we analyze the global sea level rise phenomena, we can see the sea level rise is different in different parts of the world. These are mainly because of four different reasons. First, temperature. Because hot water is more voluminous than cold water, sea level in the tropics may rise faster. Winds. A region's dominant wind have an impact on the morphology of the seas. Ocean currents. Changes in oceanic currents could be caused by global warming, which would have a direct impact on local sea level rise. And finally, the morphology of coasts and tectonic settings can also influence a location's setting and sensitivity to sea level changes. The sea level is measured in relation to the land surrounding it. The elevation of land, like the water, can rise and fall throughout the time. The immense weight of a glacier on land, for example, pushes the land down, bringing it closer to sea level. If the ice retreats or melts and its weight is removed, the same land bounces back, a phenomena known as post-glacial rebound. The effect of sea level rise, however, is very significant, especially in India. If we see a specific study, we can actually notice that by 2040, Mumbai's sea level will rise by 0.12 meter compared to 0.4 meter in 2020. At Hiran Point in the Sundarbans, the sea level will rise to 0.17 meter compared to 0.06 meter in 2020. In Chennai, the rise will be 0.10 meter by 2040 in comparison to the 0.03 meter in 2020, and in Cochin 0.15 in comparison to the 0.06 in 2020. Apart from that, when we go to the global estimations, the expected global mean sea level increase by 2100 compared to 1995 to 2014 period will be 0.28 to 0.55 meter under a very low greenhouse gas emission scenario, and 0.98 to 1.88 meter under a very high scenario according to the IPCC. As the sea rises further upshore, it will seep into the groundwater sources that many coastal communities rely on for drinking water. Aquifers or groundwater sources are vital freshwater springs, accounting for most of the world's freshwater. Freshwater is becoming contaminated due to salinity intrusion, generating freshwater shortages. With rising sea levels, water salinity and soil salinity along the coast will grow, damaging the typical properties of coastal soil and water. This also directly impacts the agriculture and livelihood of farmers. Due to a shortage of freshwater and soil degradation, it promotes salinity intrusion, which reduces agricultural yield. Salinity also affects the agriculture sector by lowering the germination rate of some plants. According to World Bank research from 2000, increased salinity from 0 to 0.3 meter rise in seawater level will result in a net loss of 0.5 million metric tons of rice production in the coastal area. Salinity intrusion decreases soil quality and inhibits rice production. The availability of light for corals will also be reduced as sea levels rise, disrupting the photosynthesis process for them. Reduced photosynthesis will stunt coral growth, resulting in the extinction of St. Martin's Island, the country's only highly productive coral island, and for other countries in the Southeast Asia and South Asia, other coral islands are also there. Now, talking about the impact of main land area, sea level rise causes erosion by raising the sea level, which washes away the topsoil along the coast, making the coast steeper. Furthermore, the backwater effect is accelerated by rising sea levels, which will result in erosion. Bangladesh is one of the countries most affected by sea level rise. With vast number of people displaced each year owing to floods, IPCC 2001 report shows that it anticipated loss by 1 meter of sea level rising, 29,846 kilometers square of land, and 14.8 million people got landless in Bangladesh. Past studies on the impact of a 1 meter increase in sea level along the Indian coast indicate the territory that could be flooded and the population that would be impacted if no preventive measures were adopted. It has been projected that a total area of 5,763 kilometers along with India's coastal states, or 0.41%, might be flooded, with over 7.1 million people, or 4.6% of the coastal population, directly getting affected. The Kutch region of Gujarat, Mumbai, and South Kerala are the most vulnerable places along the Indian coastline. With a 1 meter rise in sea level, the Sundarbans will be submerged. Heritage, biodiversity, fishing resources, lives, and livelihoods would all suffer as a result. Salinity infiltration has caused the top dying of Sundari, the Sundarbans' most important tree species. If the alarming rate of rising sea levels continue into the next century, the land will be lost. But a large population living near coastal cities would be forced to relocate. Because three massive national highways in India pass near the ocean, there may be a loss of the existing road network near the sea. The control of salinity and the management of biological species and flood protection measures should be a top priority for policymakers. Climate. Now, if we move on and see the observations happened regarding the Indian Ocean seas, we will see that the study refers that a distinct spatial pattern in sea level increase during the 1960s by combining ground and satellite observations of Indian Ocean sea level with projected climate change models. The researchers discovered rising sea levels in some parts of the Indian Ocean, but significant drops in the southern tropical part of the same place. The Indian Ocean is the world's third largest ocean, containing over 20% of the planet's surface water. A large reservoir of warm water stretches from Africa's east coast to the Pacific International Date Line within this ocean. In the last 50 years, a lot has changed. The warm lake in the Indo-Pacific has warmed by roughly 0.5 degrees Celsius. Sea levels have risen by an average of 12.7 millimeter each decade along the northern Indian Ocean coast. The Bay of Bengal, the Arabian Sea, Sri Lanka, Sumatra, and Java are all affected in some way. Increased rainfall in the eastern tropical Indian Ocean and drought in the western equatorial Indian Ocean could result from these changes in regional ocean pattern and sea levels, which could worsen flooding and different situations caused by monsoons in Bangladesh, India, and other subcontinental countries. Climate change impacts on the Indo-Pacific warm pool could result in much larger sea level rises than the global average for islands in the middle of the Indian Ocean. As a result, several Indian Ocean shores and islands as well as their inhabitants may face heightened environmental stress. Mitigation and adaptations are the two primary categories of climate change responses. The goal of mitigation is to stabilize the climate system through reducing greenhouse gas emissions and sequestering greenhouse gases in forests, among other things. Mitigations can be considered to avoid a unmanageable scenario caused by major climate change, since it tries to maintain climate change within the level to which human society and the ecosystem can adapt. A large-scale irreversible shift, including the breakup of the GIS and WAIS, is part of the unmanageable condition. Adaptation, on the other hand, aims to mitigate the negative effect of climate change through a variety of strategies such as catastrophic risk reduction and greater food production and freshwater supply resilience. Even if mitigation succeeds in stabilizing the climate, climate change will continue to progress to some level, causing some repercussion on industries and regions. As a result, adaptation is regarded as a preparation for an inescapable impact. Adaptation planning and implementation are critical, especially for developing countries, which would be hit harder due to their inadequate infrastructure and low adaptable capacity. Given the uncertainties surrounding international mitigation agreements, adaptation is becoming increasingly important day by day. For managing the seawater level, we can reduce the carbon footprint. Different study shows the increase in carbon footprint increases the global warming, causing the immediate yet delayed effect of ocean water increment. Therefore, there is a high possibility if we can reduce our carbon footprint significantly, we will be able to feel the effect of the same hundreds of years later regarding managing the rise of seawater level. The phenomena of wetlands and sea level rise is quite intertwined. Wetlands turn themselves to halophytic forests with more salt water coming in eventually. However, the main passage of coastal sea water to soak up through the landmass or release of the height of the same water surface are these places either by coastal vegetative barrier or by paving path for the backwater as additional reserve. The most common, effective, and the most important of all the preventive measures we can take is the planting tree and encouraging afforestation. The excess water from land cleared of forests become runoff water and enters the ocean instead of seeping downward into the soil to reach the aquifer. Hence, more vegetation can serve us reversing the phenomena. Also, it can indirectly contribute by cooling down the Earth's atmosphere as a whole as well. Then we can also take some other preventive measures like reduction of renewable energy use with different climate action plans and mechanical plannings to support the coastal area or the islands and to get rid of the drastic effect of the rising ocean. So, finally, as a closing note, we can say that climate change and the ocean water level rise are two of the most remorseless threats for our upcoming future. However, these all can greatly be encountered by innovative ideas and planned development strategies, which must be taken to keep our planet habitable for us for long.